The history of galaxies is a fascinating journey spanning billions of years, from the early universe to the present day. Here's a brief overview of the major epochs in the history of galaxies. Shortly after the Big Bang, the universe was a hot, dense soup of particles. Tiny fluctuations in density led to the formation of dark matter halos, which served as the seeds for galaxy formation. Over time, galaxies settled into a more quiescent phase, with star formation rates declining and galaxies transitioning into a red and dead state, dominated by older stars. Since dark matter dominates the mass of galaxies, simulations often begin by modeling the formation of dark matter halos. These halos form through gravitational collapse, as tiny density fluctuations in the early universe grow over time. Simulations use n-body techniques to track the evolution of dark matter particles under the influence of gravity. Once the dark matter halos are in place, simulations incorporate the dynamics of gas. Gas cools and condenses within dark matter halos, forming galaxies. Simulations model the hydrodynamics of gas, including processes like cooling, heating, star formation, and feedback from supernovae and active galactic nuclei. Simulations generate the visual appearance of galaxies by tracking the distribution of stars and gas. Depending on the simulation's resolution and complexity, galaxies may exhibit a range of morphologies, including spirals, ellipticals, and irregulars. Finally, scientists compare the properties of simulated galaxies with observations from telescopes and surveys. This iterative process helps refine the simulation parameters and improve our understanding of galaxy formation and evolution. Dark matter halos are the gravitational scaffolds upon which galaxies form. Simulations use n-body techniques to track the gravitational evolution of dark matter particles. These particles interact only through gravity and form clumps and structures over cosmic time. In more sophisticated simulations, the dynamics of gas are also included. Gas interacts with dark matter through gravity and with itself through pressure, viscosity, and other hydrodynamical forces. Simulations solve the equations of fluid dynamics to model the behavior of gas within dark matter halos. Baryonic physics refers to the processes involving normal matter, gas and stars, in galaxies. Simulations incorporate various physical processes, such as gas cooling, star formation, supernova feedback,